Hello viewers, I am Dr. Mala Das Sharma, retired professor of St. Pius 10th degree and PG College for Women, Hyderabad. You are watching my channel Chemphilic, so let's start the 20th episode of Teaching Chemistry through Riddle. My request is do watch the video till the end so that you can enjoy the complete riddle, and moreover today at the end of the riddle one question will appear for the viewers. Please enjoy it. So let's start riddle number 20. X is a property of certain solution where mole fraction of the solvent is much higher than solute. X belongs to a certain category of property of solution. X tells that dilute solution of sugar boils at a temperature slightly higher than 100 degrees centigrade. Difference in the vapor pressure of water and aqueous solution of sugar is the cause of the property X. From the expression of X, you can calculate the molecular weight of the solute. So this is riddle number 20. Now let's see the questions. First question or primary question is, what is X? Name the category of property referred in the riddle to which X belongs. We'll see the answer. The answer is elevation of boiling point, that is X. Now the category of property, that is colligative property of dilute solution. Now colligative properties of dilute solution. The certain properties of dilute solution of non-volatile solute, they do not depend on the nature of the solute but depends only on the concentration of the solution or number of solute particles present in the solutions. And these properties of dilute solutions are known as colligative properties. So, certain properties of dilute solution containing non-volatile solute do not depend upon the nature of the solute dissolved but depends only upon the concentration, that is number of solute particles present in the solution. Such properties are called colligative properties. Now the four colligative properties are, first one, lowering of vapor pressure of the solvent due to addition of non-volatile solute. Second one, osmotic pressure of the solution. Third one, elevation of boiling point of the solvent, obviously due to addition of non-volatile solute. Fourth one, depression in freezing point of the solvent. Now from these colligative properties, you can calculate the molecular weight of the solute. So colligative properties are very useful in calculation of molecular weight of the solute. Now we see the other question. Second question, why there is a difference between the vapor pressure of pure water and aqueous solution of sugar? Now third question, why the boiling point of dilute solution of sugar is higher than 100 degrees centigrade, that is the boiling point of water. Fourth question, how can you calculate the molecular weight of the solute from the expression of X? Now let's see the answer. The second question was, why there is a difference between the vapor pressure of pure water and aqueous solution of sugar? Now let's see. See, here is a volatile solvent, liquid solvent kept in a closed vessel. Now, from this solvent, some vapors are formed and those vapors exert a pressure on the surface of this liquid. So, at a particular temperature, the maximum pressure exerted by the vapor on the surface of the liquid is known as the vapor pressure of that liquid at that temperature. If the amount of the vapor forms is more, say you have increased the temperature, vaporization is more and more amount of vapor is formed. In that case, pressure exerted by the vapors also will be more because more amount of vapor is there. So vapor pressure also will be more. So vapor pressure of the liquid, that means the volatile liquid, is the pressure exerted by the vapor on the surface of the liquid when it is in a closed vessel at a particular temperature, is the vapor pressure of that liquid at that temperature. Now, all volatile liquids give up their vapors at one or other temperature. If the liquid is kept at a closed vessel, then the maximum pressure exerted by the vapor on the surface of the liquid is known as the vapor pressure of the substance at a given temperature. Now, when a non-volatile solute is added to this liquid, pure liquid or pure solvent, then vapor pressure of the solvent is lowered down. That means the vapor pressure of the solution is less than that of the pure solvent. Now, why it is so? See, here we have taken pure solvent in a closed vessel. So, from this pure liquid, this is volatile liquid, so it is converted to vapor slowly, and the vapors are present above the liquid, and this vapor, when it exerts the pressure on the surface of the liquid, that is the vapor pressure of this pure liquid at that temperature, that particular temperature. Now, when you have added little amount of non-volatile solute, say these are the non-volatile solute, then this non-volatile solute, they cannot vaporize. So, and moreover, they occupy certain portion of this liquid surface. Then, from those portion, volatile liquid or volatile solvent cannot get vaporized. As a result, amount of vapor form, which vapor? Vapors of the solvent form is less. So, when the amount of vapor form is less at the same temperature, then the pressure exerted by the vapor also will be less. That means vapor pressure is less. So, vapor pressure of the solution is less, or the vapor pressure of the pure solvent is lowered down due to addition of little amount of non-volatile solute. So, this decrease in the vapor pressure of the solvent is caused by the presence of few molecules of non-volatile solute at the surface, with a result a fraction of the surface of the solvent is blocked to evaporation. But just now I explained. So, if P0 is the vapor pressure of the pure liquid or pure solvent, and P is the vapor pressure of the same solvent after addition of little amount of non-volatile solute, then P will be less than P0, and the lowering of vapor pressure will be P0 minus P. Now coming to third question. If the boiling point of dilute solution of sugar is higher than 100 degrees centigrade, that is higher than the boiling point of water. So, first we will explain boiling point and then elevation of boiling point. So, what is boiling point? Boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure, that is 1 atmosphere or 760 millimeter of mercury level. Okay. So, the boiling point of a liquid is defined as a temperature at which its vapor pressure becomes equal to atmospheric pressure, that is 1 atmosphere or 760 millimeter. That is the normal boiling point. Now, so this is the pure liquid, and from the liquid, which is volatile pure liquid or solvent, from this liquid vapors are formed. That vapors are exerting pressure on the surface of the liquid, and that is the vapor pressure of the pure solvent. Right? When you are adding this non-volatile solute, say this red one, it occupies some portion of the surface, and obviously amount of vapor form is less, by the vapor of the solvent is less, and then vapor pressure exerted by the vapor also less. That means vapor pressure decreases. So, to make the vapor pressure of the solution, equal to that of atmospheric pressure, more vapors are required. How can you get more vapors? You have to heat the solution. That means you have to increase the temperature so that vaporization increases with temperature, so that more amount of solvent vapors is formed at a higher temperature, and then the vapor pressure of that solvent will be equal to atmospheric pressure in case of the solution, and then it will start boiling. So solution boiling point is more than that of the boiling point of the pure solvent. So since the addition of non-volatile solute lowers the vapor pressure of the solvent, solution always has a lower vapor pressure than that of the solvent, and hence it must be heated to higher temperature to make its vapor pressure equal to atmospheric pressure, with the result the solution boils at a higher temperature than that of the pure solvent. Now fourth question. How can you calculate the molecular weight of the solute from the expression of X? X is elevation of boiling point. So we see elevation of boiling point. So just imagine that there is a pure solvent whose boiling point is T0. When you are adding little amount of non-volatile solute, say sugar, then the solution start boiling at a temperature T. Obviously, T will be higher than T0, already I explained. Then the elevation of boiling point delta TB will be equal to T minus T0. That is boiling point of the solution minus boiling point of the pure solvent. Okay. Now you see this graph. This is the vapor pressure temperature curve. Now the first one, that is AB, this is the curve for pure solvent. Now second one, that is CD, this is the curve for solution number 1, where you have added little amount of non-volatile solute, say sugar. The third one, EF, this is the curve for the solution of 2, that is second solution, where you have added little more amount of, compared to first one, little more amount of sugar or non-volatile solute, right? Now look at the first curve, AB, which is for the pure solvent, right? And its boiling point is T0. And at this boiling point, its vapor pressure is P0, that is 1 atmosphere. Now, at the boiling point of pure solvent or T0, the vapor pressure of solution number 1 or first solution is P1. Obviously, here you see P1 is less than P0. Okay. So, here at the boiling point of the pure solvent, this vapor pressure is decreased due to addition of non-volatile solute. It is not P0, it is P1. Then, the lowering of vapor pressure will be P0 minus P1. And this first solution, you have to heat more, so that more amount of vapor form and the vapor pressure will be equal to atmospheric pressure P0. Then if you heat it more, then at temperature T1, its vapor pressure is becoming equal to P0 or 1 atmosphere. That means T1 is the boiling point of the first solution and T1 is greater than T0. So elevation of boiling point is T1 minus T0, and lowering of vapor pressure of the first solution, already I told you, that is P0 minus P1. So P0 is the vapor pressure of the pure solvent at the boiling point T0, and P1 is the vapor pressure of the solution 1 at the boiling point of the solvent T0, that is P1. The lowering of vapor pressure due to addition of non-volatile solute is P0 minus P1. The boiling point of the first solution is T1 and T1 is greater than T0, and the elevation of boiling point delta TB will be T1 minus T0. Similarly, if you take the second solution, here also at temperature T0, that is boiling point of the pure solvent, its vapor pressure is P2, much lower than P0. Okay, so at temperature T0, this vapor pressure is P2. Therefore, lowering of vapor pressure in this case is P0 minus P2 at temperature T0. Then you have to heat the solution more, so that at temperature T2, its vapor pressure become equal to atmospheric pressure. That means T2 is the boiling point of the second solution. Then elevation of boiling point in the second solution will be T2 minus T0. Now, just you see here, this portion of the curve, this part JH, and even this part KI, this, though it is curved, it is almost similar to that of the straight line. Okay, you can assume these are straight line. In that case, this triangle GJH and this bigger triangle GKI, these two triangles are similar triangles. Similar triangles mean the ratio of the arms will be equal. That means for this triangle, this arm GJ, how much will be the GJ? GJ will be P0, this one, minus P1, this one. So that only this part. Okay. So GJ, this part will be P0 minus P1. Okay. Similarly, for this bigger triangle GKI, this arm, what will be this arm? This is total P0 minus P2. So this part will be P0 minus P2. Okay, this ratio of this arm I have taken. That will be equal to ratio of these arms. So how much will be this one? JH. JH will be T1 minus T0. Okay. Similarly, how much will be this one? KI. This part. This part will be T2 minus T0. So T1 minus T0 by T2 minus T0, that will be equal to P0 minus P1 divided by P0 minus P2. From this similar triangle rule we have written. So therefore from this equation I can write lowering of vapor pressure P0 minus P will be proportional to this elevation of boiling point, that is delta T. Now, Raoult's law of dilute solution. We have to explain it first. According to Raoult's law of dilute solution, relative lowering of vapor pressure. What is relative lowering of vapor pressure? Lowering of vapor pressure divided by the vapor pressure of the pure solvent. So, relative lowering of vapor pressure due to addition of non-volatile solute is equal to the mole fraction of the solute in the solution, provided solute must be non-volatile, solution must be dilute, and solute should not undergo any association or dissociation. So, according to Raoult's law, we can write relative lowering of vapor pressure P0 minus P by P0 is equal to the mole fraction of the solute, that is X2. Now, mole fraction of the solute, we know that number of moles of the solute divided by total number of moles, that is number of moles of solvent plus number of moles of solute. Now, number of moles of solute is N2, total number of moles is N1 plus N2. Now, as the solution is very dilute, so we can neglect this N2, number of moles of the solute, in comparison to N1. So, this equation we can consider it as N2 by N1. Now, what is N2? Number of moles of the solute, that is weight of the solute divided by molecular weight, W2 by M2. Now, divided by N1. What is N1? Number of moles of the solvent, that means weight of the solvent divided by molecular weight of the solvent, that is W1 by M1, that M1 goes up. So, this is the equation. Now, therefore, from this equation I can write P0 minus P is equal to W2 into M1 into P0 divided by W1 into M2 from this equation. Now, again, we know molality of the solution or molar solution. Molality of the solution is number of moles of the solute present in 1000 gram or 1 kg of the solvent. Now, number of moles of the solute is W2 by M2, which is present in W1 gram of the solvent. Then how much present in 1000 gram? That will be multiplied by 1000. So, this is the molality. So, from this equation, molality here I have denoted by small m. From this equation, we can write m by 1000, this small m by 1000 is equal to W2 by M2 into W1. Now, then, in case of P0 minus P, this equation, in this place, that is W2 divided by W1, M2, I can write M by 1000. Okay, so M by 1000, remaining are same. M1, this is molecular weight of the solvent, and P0. Now, this part, that is M1 P0 by 1000, it is a constant. So, therefore, what we can say? P0 minus P proportional to molality of the solution. Earlier slide, I have shown you that this P0 minus P proportional to elevation of boiling point. So, we can write elevation of boiling point proportional to molality of the solution. So, delta TB proportional to M. If you want to remove the proportionality, then delta TB is some constant Kb into M. Kb is known as the molar elevation constant. Okay. When this M is equal to 1, that is molality is equal to 1, then delta TB will be equal to Kb. So, therefore, when molality is equal to 1, delta TB is equal to Kb. So, molar elevation constant can be defined as the elevation of boiling point when molality of the solution is 1. So, molar elevation constant is the elevation of boiling point by the addition of little non-volatile solute when molality of the solution is 1. Now, delta TB is equal to Kb into M. M is molality. Molality, this is the expression already I have derived here. That is number of moles of the solute divided by weight of the solvent. Okay, multiplied by 1000. So, from here, this is the molecular weight of the solute. So, from this equation, I can write molecular weight of the solute M2 will be equal to Kb W2 into 1000 divided by delta TB into W1. That means you can calculate the molecular weight of the solute from elevation of boiling point. So, this was our riddle number 20. Now, a simple and funny question related to this riddle number 20 will appear on the screen for the viewers. Let's see. So, today's funny question for the viewers. Why the boiling point of water is 100 degrees centigrade? I think all of you can answer the question. So, please mail your answer to the mail ID malachemphilic@gmail.com. You have to write, in the mail you have to write first your name, affiliation and place, that means which institution, school, college or any other institution, organization and place. And then write answer of the viewer's question of riddle number 20 and then give the answer and mail it to the above mail ID. Time to time, I'll announce the name of the viewers who will give the correct answer. Please join me in this program. Thank you.